Hello and welcome to the Daily Space for today, October 18th, 2019. I am your host, Dr. Pamela Gay, and I am here to put science in your brains. Today we have a variety of stories coming to you from all across the universe, and our first story is one of those that reminds me that science generally falls into a few different categories, or at least science discoveries do. Over the years, I've had the opportunity to read a lot of journal articles, to read more press releases than you can shake a stick at. And what I've seen is these new results tend to emerge either from massive long-term studies that were done bit by bit with slow and gradual and amazing progress, or they were the result of, well, someone being in the right place at the right time, or pointing their telescope at the right place at the right time, and having the knowledge and the training to know what remarkable thing it was that they were seeing. But there's one other category of science, and this is the category of people who come up with some, I wonder if, that in retrospect seems kind of obvious. But they're the first person with the creativity to think of that thing and change how we're able to make observations of our universe. This particular story is one that, well, points out observationally that extrasolar worlds are made of the same chemistry that we see here on our planet, which is kind of remarkable because we can't even go to Mars and do a core sample of Mars to make sure it's made of the same stuff that our world is made of on the inside. But they're saying this about other planets. And the way they're able to do this is this team in a new paper led by Alexandra Young, looks at 6 different white dwarf stars, and in looking at them, looks for the chemical signatures of planets being disrupted by the white dwarf. Now, in general, when you look at a white dwarf star, these hot stellar remnants should only show the spectral signatures of hydrogen and helium. And when you see other things, when you see heavier elements, it's not that these are heavier elements that originated with that star. Those would have all sunk to the core. What you're seeing is heavy elements from the planets that had previously orbited these stars and have, through one way or another, met their demise. And in looking, I'm being told only the chat is showing. Oh, sorry. Here we go. In looking at these objects, here we see an artist's illustration. What we're able to see is elements like silicon, magnesium, and even, well, iron oxide. And iron oxide means that these worlds once had some of the same geochemical processes on them that has led to iron oxide, which is a fancy word for rust, here on Earth and Mars. So, thanks to a bit of creativity, these scientists took a kind of star that's generally only of interest to astrophysicists and turned them into laboratories for doing planetary science. This is a great combination of the two fields that in many ways are very, very separate, coming together to tell us that, well, other solar systems resemble our own. To quote Young, we're doing real geochemistry on rocks from outside our solar system. Most astrophysicists wouldn't think to do this, and most geophysicists wouldn't think to ever apply this to a white dwarf. One side effect of this research is it also means that someday, billions of years from now, when our own sun has puffed off its atmosphere and left behind a white dwarf core, well, someday, billions of years from now, people looking back at our solar system may be able to measure the chemical composition of our worlds using this exact same technique. Now, the death of stars is pretty much just on par for what goes on in our universe. And as we look out across the sky, we can, with telescopes on a regular basis, see the explosion of supernova in distant galaxies. There's roughly one supernova per galaxy like our own every 100 years, which means that if you look at 100 such galaxies for 1 year, you'll see one supernova. Or it means that if you hang out long enough in our galaxy, you'll see a supernova. And back in 1572, Tycho Brahe looked up and was able to see a bright new star arising in the constellation Cassiopeia. Now, when we look at this region today, it looks like a regular, everyday area of the sky, nothing too exciting. But that supernovae that Tycho Brahe and many, many others observed going off, well, when we look at that region of the sky in X-rays, what we see is the high energy emissions of an expanding shock wave moving out through space. We can combine these results, the optical and the X-ray, to get at what appears to be a bumpy and lumpy expanding wave of material. Now, in order to figure out exactly what we're seeing, scientists have over and over across the years observed this system with the Chandra X-ray Observatory. And in the most recent set of observations, they zeroed in on X-ray emission from the atom silicon. And in looking at this particular gas, they measured motion towards us, motion away from us, and measured the structure of this cloud. And what they determined is these pockets of color that we see in this image are actual lumps and bumps within this expanding gas. And when you step back and you try and figure out how do you get something that looks like this over this large of a volume of space, well, winding things backwards and looking at complex computer models, what they figured out is when this supernova, a type 1a supernova, the kind that we use to measure the expansion of our universe, when this supernova went off, it didn't detonate smoothly with the entire core of the prior massive star going boom all at once. Rather, it ignited in a variety of different places. And what we're seeing is the echoes of that, well, distribution of places that exploded in different moments, the variations and the detonations that have led to a non-smooth surface to this expanding supernova remnant. Now, we still have a lot to learn about type 1a supernova. And it's research like this that puts new constraints on our models and helps us piece together, well, are type 1a supernovae the same over the course of the history of the universe? Have they changed over time as the chemical composition of our universe has changed? There's so many different things that we still need to try and understand. And this one detail brings us that one step closer to understanding what is going on. And it's kind of cool to think that supernovae don't go boom all at once, but rather those animations you've seen in some science fiction movies of various points on the surface detonating, well, that myriad of detonation points, that appears to be what is actually happening in these systems. Okay, so from one sphere of science, we now move on to another. And this is one of those things where I remind all of you that Earth is a planet, planets are cool, and planets are filled with really weird geology and chemistry. What you are seeing in this image is a roughly 2 meter across sphere that is filled with crystals. This is the kind of thing that you may be used to finding in fist sizes. Um, it's a geode. There's lots of different places here in the United States where roadside attractions include grabbing a geode out of a barrel, paying however much you pay, hitting it with a hammer, cracking it open to see what crystals may or may not lurk on the inside. Well, this particular 2 meter diameter geode was found 50 meters under the earth in a lead mine in Spain. And it's raised the question of how does this happen? How did this get to be here? This isn't the only such giant crystal geode or cave that has been found on the Earth. There's another one much larger in Mexico, but the one in Mexico we understand because it's geologically active with moisture continuing to trickle down into the cave, carrying with it the solutions of salts and minerals that are necessary to grow this kind of a crystal. But this one in this picture, this isn't geologically active. This is actually a fossil geode, if you will. It exists in a completely boring area. Well, it has lead that is being mined, but other than that, it's a boring area that isn't currently active. So scientists, well, prying through the dirt and trying to reconstruct the historic geology of this area, have come to the conclusion that what we're seeing is the result of water seeping down through anhydrite rocks. This is a calcium salt dissolving those calciums in the soil. And as they trickle down, well, the small crystals that got dissolved instead, well, that material gets implanted on larger crystals that grows them bigger and bigger and bigger. This is a complex process. And what's remarkable about this particular process is because it took place in a fairly constant environment over long periods of time, the crystals that grew are remarkably transparent. They don't really have gases trapped within them. And this makes it even harder to figure out things like what is the age of these crystals. It's currently estimated that this particular geode formed between 60,000 and 2 million years ago, which is a pretty large swath of history. But hey, it means that future scientists have a big old question to solve, and that's how old this system is. This is just kind of awesome. This isn't the kind of thing that you can build over a lifetime. This is the kind of thing that grew over generations of humans. And now is there waiting to be explored. But as is pointed out in the Science Alert article that I read, make sure you only go into it with someone you like because it's sharp and pointy on the inside and you don't want any pushing to take place. All right, so that's the new news for today, but I do have updates on news stories that we brought to you in the past. The first update comes to us from the InSight mission on Mars. As we have told you before, the InSight has two instruments, a seismograph that works brilliantly and a temperature measurer that is currently not doing its job. This device, referred to as the mole, was originally planned to dig its way roughly 5 meters under the soil of Mars and measure the temperature profile of the soil as it digs its way down. But it got stuck. And for the past year, basically, they've been trying to get it unstuck and get it digging deeper. And most recently, they had decided that it wasn't actually stuck on a rock as originally thought, but instead, the soil of Mars was sufficiently loose that it couldn't get enough friction to drive itself downward as planned. So the slightly insane technique they came up with to fix this was to take the shovel of InSight and wedge the probe slightly sideways with the shovel to increase the friction on the probe. And this seems to have worked. In the past week, the probe has been able to descend an extra couple centimeters, which is more than it's been able to descend in many months. Now, a couple centimeters in a week isn't all that impressive when you want to go down 5 whole meters. And here's to hoping that they're able to accelerate the digging process as they continue to burrow down. It's thought that one of the reasons things are going so slow now is all the past thumping that this device did in trying to dig simply compressed the soil beneath it. Hopefully, things will loosen up as it continues to burrow deeper and deeper and deeper. So, moving on to another update. Last week, we got to share with you the happy news that ICON had finally launched. Originally scheduled to launch in 2017, this poor explorer has gone through all manner of difficulties in getting itself launched. It was slated to be launched on a Pegasus rocket that was dropped from an aircraft. And there were a number of difficulties that we've gone into in the past. And it turned out that it wasn't the rocket, but it was something else that almost prevented launch last week. It has now come out in a story from California and the University of California, Berkeley Space Science Laboratory that they were almost prevented by NASA from launching due to power problems at the University of California, Berkeley. Last week, PG&E, the power company in the state of California, cut off power to roughly 2 million residents and businesses, 2 million customers, because of concerns of wildfires being sparked by those power lines. This is something that happened last year, quite tragically, leading to a number of deaths. And if you're a business person, also leading to a great deal of profit loss for PG&E. This year, in the fullness of caution, PG&E has been shutting down power rather than risk fire and the costs associated with that fire. This hasn't always been the best of solutions. There has been at least one death associated with these power outages. And for the University of California, Berkeley, there was also almost a non-launch. The reason is NASA kind of requires ground control for any particular satellite to be fully functional and fully powered when that satellite launches. And P&G was planning, and actually did, shut down the power to the University of California, Berkeley at the planned time of launch. In order to allow this launch to go forward, well, the first thing they did was survey what's going on at Berkeley, and Berkeley does have its own independent power generator, but the power plant at Berkeley isn't really enough to maintain everything as much as is needed to make sure the launch went smoothly. So what they did was they got not just one backup generator, which they already had, they went and got a second as well as all of the gas and everything else. And they wired everything together in a massive astrophysical MacGyvering of power generation. And they kept their ground control going, and ICON was able to launch. So, unintended consequences. There were many of the power outage last week, and it wasn't enough to completely stop fires from occurring. There was a fire that I was actually able to witness that broke out not because of the electrical power grid, but rather because there was a garbage fire, and when the garbage fire ended up inside of a garbage truck, the garbage truck dumped the garbage, and the fiery garbage set fire to the mountains outside of northern Los Angeles. So the combination of climate change and the spread of humans into remote areas is going to change how we have to live in coming years. And that is a story that we're just going to have to watch over the coming years. And here's to hoping that rain and an end to the winds in California comes quickly and the fire hazards drop away. Okay, on that not entirely cheerful note, that's all I've got for today. Please go ahead and ask me any questions you may have and put those questions in a purple circle containing a purple star. That will help me find your questions. While you type those in, I just want to remind you that you are watching The Daily Space. My name is Dr. Pamela Gay, and I and my co-host Annie Wilson bring you The Daily Space most Mondays through Fridays at 1 p.m. Eastern, 10 a.m. Pacific. Eddie, go around the other way. Come over here. Sorry, I'm going to try something new today. As you know, I give Eddie treats when you guys are good humans and give us bits. And I'm going to try and train him to come around the other side. Nope, get down. Come over here. Come underneath. Here, come underneath. Come on. That's it. Move the camera. Come over here. See? Now you can come up. Good boy. This is what I want you to do from now on. See, an old dog can learn new tricks. Hi, I see you. Are you very pleased? You are. So thank you everyone for the bits. Now you've discovered where I keep them. We are a production of the Planetary Science Institute, a 501c3 nonprofit dedicated to exploring the solar system and beyond. We are produced by the ever fabulous Susie Murph, who is responsible for making sure that our podcast editions get put out to our patrons every single day, along with transcripts, and that everything goes up on our website, dailyspace.org. If you ever miss one of our episodes, you can find them over on YouTube, youtube.com/c/CosmoQuest. And if you would like something audio only without barking dogs, I know Stella let us all hear her earlier in this episode, you can catch those in our podcast edition. Hi, you're going to move my desk. That you should be able to find in your favorite podcast directory. Okay, so let's see what questions we have. I'm dealing with the new layout for Twitch. There we go. The chat was a bit narrower when I started. So Paranor has subscribed for Tier 1 for 14 months. Thank you so much, Paranor. That is amazing. He is also one of the bestest of mods. Just laying that out there. Okay, so let's see. What does it take to get my desk back where it belongs? Looking for questions. Thank you, Refs Matt, for the bits. So Chemist 1902, I almost missed your question, but I did catch it. I hope you're still here. Chemist 1902 asks, do you help with physics or cover physics concepts? If yes, when will be the next physics stream? So we are a channel mostly dedicated to physics and astronomy. To astronomy and planetary science, rather, not physics. We're happy to answer physics questions in general, but we don't have any dedicated physics streams. Let's see. Looking for. So Larry says, my big question, do protons decay? I think that is everyone's big question. And the reason this is a big question is all of our current understandings of the standard model of particle physics trying to get Eddie to understand to come around. All of our current understanding of particle physics requires protons to decay. You need to come around. Hi. Okay, new dogs can't always learn new tricks. One moment. We're working on training. I'm sorry I'm doing this on air. Come on. See this? Come on. Nope. All the way over. Come on. Over here. No. You. Good boy. Come on, over here. Up. Okay. Here we go. Okay, there we go. All right. So yeah, all of our current big questions about particle physics are based on the assumption that protons decay, because that seems to be what falls out of the math. But no matter how hard we look, we don't see proton decay. And with all the experiments that have been going on for as many years as they have been going on, we would have expected to see it by now. So this is one of those things about particle physics that is deeply confusing, and we're all still trying to figure out. I like that Merlin's symmetry describes the crystal chamber. That's the supernova remnant. Describes the crystal chamber as being Merlin's sleeping chamber. I like that. So let's switch over to the chat. How about? Come on, you can switch. Sometimes I just press buttons and it imagines that it's doing things and it doesn't actually do the things. There we go. Okay, now we have the chat on screen. Veronica Cure comments regarding the crystal chamber. All the jewelry you could make with that. Yeah, Arnstro highlights an XKCD comic that has a description of just how ridiculously bright supernovas are. The average brightness of a type 1a seen from one astronomical unit, which is the distance from the Earth to the Sun, is 1 billion times brighter than a typical hydrogen bomb pressed against your eyeballs. So yeah, it's a bit bright, just a bit bright. Looking for other questions. So Chemist 1902 says, in the list of streamers in TKF, it says, I do astronomy, physics, and programming. When is your next physics stream? So it probably should be astronomy, planetary science. I mean, physics is part of astronomy. That does come up, but we don't do dedicated physics streams. Sorry about that. So Veronica asks, if we leave crystals alone in the right place, will they grow this big? Presumably. I mean, I'm sure that there's other things that have to be taking place. Their ability to grow outwards and have that hollow in the center. I'm not sure what is required of the surrounding materials to allow that to happen. But yeah, this should be a thing. Paranor asks, could a geode like the one you showed, only 50 meters down, be pushed up by uplifting of plates, do you think? I have no idea, but I know that crystals like this can actually be melted. So I suspect that had this started too deep down, it actually couldn't have started too deep down because the heat would have prevented the crystals from forming. The way they describe this is they actually believe that it formed in situ, where the temperature would have been roughly a constant 20 degrees Celsius with day-night fluctuations around that. And it's at that temperature that this kind of crystal formation can take place. Looking to see what other questions. Mythtown asks, can we blow up Bennu? No. Then we would end up with a cloud of material in an Earth crossing orbit. And I'm sure some of the pieces would love to come visit. That wouldn't be good. Let's just leave it the way it is. Oh, something occurred. Something occurred. Thank you, Fenmil, for gifting a sub to D7V1D. Thank you. Let me see if I can get Eddie to come back around to the correct side of the table. I want you over here. So Raj Luthra asks, is anyone else watching the All-Female Spacewalk? Clearly, I am not right now. I have heard that everything is going well. And the thing that I really like about this is for a long time, space had become completely ordinary. Where are you going? No, sit. And one of the side effects of space becoming completely ordinary is people didn't watch spacewalks. They didn't watch when things was going on, when construction was taking place. And this moment that should have happened 1,000 times by now, well, maybe not 1,000, but at least many times by now, of two women being on a spacewalk together. This moment is bringing all of the exploration that's being done in space to the forefront once again, getting people to pay attention to space exploration. Broken Symmetry asks, is the fact that we don't see solar systems that look a lot like ours indicative that what we are seeing is how our solar system used to look? So we don't actually have the technology yet to be able to see solar systems that look identical to our own. We're just starting to be able to detect terrestrial planets around some stars. It's hard to detect small worlds. So what we're seeing right now is a significant sample bias, where because we can easily see large worlds, we're easily finding solar systems that contain large worlds. Now, that doesn't mean that's the typical solar system. That just means that's the typical solar system we are able to see. So ask your question again when we have better technology and better samples. Looking to see what else is in here. Eddie is our mascot. Tink is a close second. This is true. This is true. He's a happy dog right now. I do need to figure out how to give him better traction up here, though. Yes, as Hexacosacoron points out, we have over 500 episodes of Astronomy Cast at this point. I love the countdown that's going on in chat towards Astronomy Cast. Okay. So Paranor, I actually can't lock the wheels on this desk. I just have cheap wheels that don't lock. The wheels are a aftermarket edition where I had wheels that weren't used on a cart, and I drilled holes in the bottom of a very old wooden desk I had, adding the wheels. So I need to be able to move my desk around. I'm not going to duct tape them. I will figure out higher friction for Eddie when he's sitting on the piano bench with me. Anyways, I need to go record the podcast edition of this show and prep for Astronomy Cast. Today's episode is on how our thoughts about what makes a habitable zone have wildly changed and continue to wildly change as we think about planetary science and astrobiology. So join us right here in an hour and 22 minutes, where Fraser Kane and I will come to you live from our YouTube channel and be simulcast right here on twitch.tv. So thank you all for being here. There should be painting this weekend. Everything should be returning to a normal store for a little while. Not a store, a normal schedule for a little while. Can't read and speak at once. So yeah. And that's all I've got. So wherever you are in the world, have a fabulous morning, evening, or afternoon. And I'll see you on the other side. Bye-bye.